We're going to start the second part of lesson 3 with a little bit of review and the practice test. Like I said, the practice test is what I make the test from, so I like to practice a little bit each day. Number 4 asks us to evaluate. Remember, I was trying to explain to you the difference between evaluate and solve. When there's no equal sign, you may be asked to plug values in and evaluate. When there is an equal sign, then they're going to use the direction solve. So I want you to see the difference between these two and do these both. So if you could turn off your video, do number 4 and 5 on your own, and then come back and we'll check them together. Okay. For this first one, we are plugging in -8. And anytime you plug in a negative, and this is huge for the rest of your math life, anytime you are plugging in a negative, it must be in parentheses. Because see how I have a minus right there, and then I have the minus there. So without that, students tend to combine the negative into one negative, and there's not one, there's two. So this turns into 3 parentheses 8 minus -8. And we all know this means the opposite of -8. The opposite of -8 is positive, so we immediately turn this into plus. And you have two ways you can do this. Probably the most common way is follow order of operations. Do what's in parentheses first, then multiply by 3. But you could also find the answer by distributing 3 times 8 times 3 times 8. But I do like to rewrite it because students tend to miss stuff when it's messy. So this is really our new problem. It's just 3 times 8 plus 8. So I, for one, think the easiest way is just to do what's in parentheses first. Please excuse my dear Aunt Sally says parentheses. So that just turns into 3 times 16. And I can drop the parentheses and use a dot, or I can keep the parentheses, doesn't matter. And 16 times 3 is 48. But you could have also distributed 24 plus 24, also 48. So what you did on that next step is solely up to you. So that's called evaluating. We didn't find the value of the variable. We were given the value of the variable. Where solve means find the value of the variable. And it's all because of the equal sign. Equal means solve. No equal sign, you're just evaluating. Okay, so on this next one, we have -4 parentheses -8 plus 2. And I don't need to worry about the parentheses because there's not a double negative there. But if you put -8 in parentheses, it's absolutely not wrong. And again, I would do this the same way I did the other one. -4, I'm going to put it in parentheses, and then -6. I kind of like to use parentheses when there's a lot of negatives, just so I don't lose them. I see that it's multiplication, but I don't lose the multiplication sign. So 2 parentheses also mean multiplication. So -4 times -6, 2 negatives equal positive 24. So nice and simple. So that is called evaluating. Next, we're going to solve. So this is like some of the problems we did in your last set of notes before we ended the video. So step 1 is we want to get the variable alone. So to get that alone, I'm going to cover this up and do the opposite. The opposite of add 5 is subtract 5, because I always deal with the x term last. That's why I cover it up, because students are like, oh, do I multiply, do I add? Always cover up the x term, and that'll tell you. Step 1, all constants to the right. So the opposite of add 5 is subtract 5. This is kind of leading into what we're doing today in class 2. So 23 minus 5 is 18. Now we have a problem just like what we did on our notes, And I showed you two different ways to do it. I like the calculator way just because it's faster, but I want you to know you could also find this answer by multiplying both sides by 6/5. I just prefer the calculator way. So the opposite of times is divide, and then that gives us a chance to practice on the calculator, so to make sure you're good on it before you take your first test or quiz. So 5/6 divided by 5/6, gone. So we get x equals, and then to type this in, remember from the previous problems, this is the division sign, this is a fraction bar. So 18 division sign, 5 fraction bar 6. And that leaves us with 21 3/5. And sometimes Alex will ask you for a fraction. Does everybody know this is not a fraction? That's called a mixed number, because students will see the directions, write your answer as a simplified fraction, and they'll put this down and they'll go, why did Alex count it wrong? Well, because you didn't follow the directions. That's not a fraction. That's called a mixed number. Now, if Alex said, write your answer as a simplified fraction or a mixed number, then yes, you could write that. So let's just practice so you know how to do it on your calculator, depending on what your directions say. So this is a mixed number. If it says write your answer as a mixed number or has no directions, you can leave that. But if it says write your answer as a simplified fraction, that will not be counted correct. So I showed you the other day this little button here, mixed number into a fraction. It's in blue, so you do second to access the blue keys, A, B, C, then hit enter, and it will change it to an improper fraction, which in the next class you take, almost all the answers are asked for in that form. In ours, it kind of varies. It'll say mixed number, then it'll say simplified fraction, but when you're solving higher level classes, almost all of them ask you to leave your answer as an improper fraction. Well, it's called a simplified fraction. Okay. So just to show you the steps again, 18 division sign, 5 fraction bar 6. That gives you your mixed number, which is the default for this calculator. But if Alex asks for a fraction, and maybe you want to label these just so you know their names. So mixed number. This is called a simplified fraction. And for some reason, students come to me out of high school and they don't think that a mixed number or an improper fraction is simplified. Oh, yes, it is. Simplified means, does anything go into 108 and 5? Nothing. So they have a hard time getting it in their head that this is called a simplified fraction. That's what it's called. So to turn it into that, again, we do second ABC, because you can see the above icon, mixed number into a fraction. And then hit enter, 108/5. And I prefer putting them in solution sets because that's usually how Alex wants them anyway. And you'll see when you do checks by hand, it's a lot easier to have an improper fraction to check rather than a mixed number. Mixed numbers are a lot harder to check. So there's a reason behind this why most of the upper level classes want this form, because they're easier to check that way. Only exception usually is when we're doing word problems. We want them to make sense. So if I go to Home Depot, I'm not going to order 108 fists of wood. I'm going to say, can you cut me 21 3/5 feet of wood? You know, if I said, cut me 108 feet of wood, they'd look at me like I have 3 heads. So in word problems, it makes sense to write it like this because this is how we see it. But in math, when we're going to be checking them and so on, it's easier to keep them improper. They just have to be simplified. Okay, so that's our little warm up for the beginning of our lesson. Actually, we're in the middle of our lesson. So we're going to be learning multiple step equations. So this is equations with both addition and multiplication in them, which we've done a couple already, but we're going to, move up into a little bit harder ones, and variables on both sides. So now we're combining. There's going to be addition and subtraction. Then there's going to be multiplication or division. And then there's going to be x's on both sides of the equal sign. So they're moving us up the ladder into harder problems. So this is a combination of both addition, subtraction, multiplication, and division. So we call these two-step problems. So my number one goal is still to get all the variables on the left and all the constants on the right. That's still my number one goal. So my variable is already on the left. So to move my constant to the right, we do the opposite. And just like I said, we ignore the variable term and we move all the constants over first. So if it helps you to cover it up or to box it, just to remember, save the variable term for last and do the opposite to get everything else over. So then we have negative 1 times x. Remember how I said to do that so that you don't accidentally, okay, 1 second. My mouse is on the record key again. I wanted to make sure to move it. So negative 1 times x equals, when the signs are the same, add and keep the sign. So negative 1x equals negative 19. Then the opposite of times is divide. So the opposite of multiplying by negative 1 is dividing by negative 1. And remember, we never change the signs. We only change the signs for addition and subtraction, not for multiplication and division. I immediately see two sets of double negatives, so I make them positive to make myself aware there are no negatives in this problem now. So 1 divided by 1 obviously is 1, so this is 1x or x. 19 divided by 1 is 19. And there you have it. So put that in solution sets. Okay, so B is just like the one we did for warm-up on the practice test. So go ahead and turn off your camera, or turn off your video, sorry, and try that one. So follow what we did on the practice test. It's just like it. And then come back and we'll check it together. Okay, to start this one, remember we cover up the x term because we do it last, and our goal is to move that number to the other side because we just save the x term for last. So you shouldn't even be looking at that. You should only be looking at the 4. Again, that negative does not go with the 4. 4's sign is a positive because it's not there. So when you're moving that 4 over, you should have subtracted 4 from both sides like we did on the last lesson. We talked about that. Don't look at the negative. That's the x's sign. 4's sign is positive, so do the opposite. 4 minus 4 is 0. So now we have negative 1/3 times x equals 1. And I always like to put that time sign in because that makes it easier for me to see what the next step is. So negative 1/3 times x equals positive 1. Well, the opposite of times is divide. So on this one, I'm going to do it by hand because it's a nice, easy one. So this was the second way we learned from the calculator. So the reciprocal of negative 1/3 is negative 3/1. So multiply both sides by the reciprocal because we learned on the first page of this packet, when you multiply reciprocals, you get 1. And that's my goal. I want it to be 1x. And so you can see this is going to be a negative times a negative, positive 3/3, which is indeed 1x. And then, so those cancel. Just give me 1. So x equals 1 times -3, -3. And I can drop that 1 in the denominator because we don't need it. If you had done it by calculator, -1/3 times x equals, what do we have, 1 there? You would have divided both sides by -1/3 and then typed it in your calculator. But like I said, I would keep switching it up. I do one by hand, do one in the calculator. Make sure you're good at both, because you don't want to feel naked when someone says, oh, no calculator on this test in an upcoming class. You want to feel confident that you can do it either way. So in the calculator, obviously these two cancel. Anything divided by itself is 1. We type in 1. Whoops, turn on the calculator, Kim. And then we hit the division sign. And then we do -1 fraction bar 3. There it is. Same answer, same problem. Well, there you have it. Nice, huh? These are pretty easy, especially when you have a calculator. Calculators make life so much simpler. Okay, so for this one, we have x's on both sides and numbers on both sides. So this is the one where we have to follow the rules that we had written on the other page. All x's move to the left, all constants move to the right. So I need all my x's over there, and as long as it doesn't leave a blank here, I start with that. So -2x, -2x. So I almost always start with the x's unless it leaves a blank on the other side. Did the opposite, that's +2x. This is -2x, so the x's are gone now from the right hand side. And I'm left with 2x minus 7 equals 10. Now I need everything without an x over to the other side. So +7 plus 7. And that leaves us with 2x equals 17. And then my last step, to get x alone, do the opposite. And remember what I said about improper fractions. That's usually how we leave our answers. So don't pick up a calculator. Don't turn it into a mixed number. Just leave it. So 17 over 2. And I know it's simplified because nothing goes into both 2 and 17. And that's how I write it in solution sets, 17 over 2. The only time you would want to put it in your calculator to make it a mixed number is if Alex said, write a mixed number. Then you could do 17 fraction bar 2, and there's the mixed number. So 17 fraction bar 2, hit enter, and it turns it into a mixed number. But like I said, no need to do that on this. And I just realized I forgot to put my -3 in solution sets up here. Okay, I'm going to let you guys do D. It combines two things that we've talked about previously. So I want to see if you guys can get that one all by yourself. The next two are special cases. That's why I don't want to wait and do that. So go ahead and do letter D, and then come back and join me. Shut off your video, come back and join me, and we'll check that one. Okay, this one we did earlier in this lesson on a separate video. We said that when bringing the variable over leaves an open space with nothing there, it's better to move your constant first. So remember how I said 95% of the time you're going to move your variable first. But if moving your variable creates a nothing there, you either 1, have to fill it in with 0, or even a better solution would be put your constant on the right first, because I showed you on that other page that it doesn't matter which order you do these. You can do the variable left first and the constant right second, or you can do the constant right just like we did here first and then move the variables so you don't have a blank spot there. So that's kind of a common error for students, is to do that. Forget the 0 and then put it all on one side and start doing it. So, okay, so we want to move the constant to the right first, since order doesn't matter. So opposite of -3 plus 3, so that gives me 1/2 y equals 5/2 y plus 3. And another thing you could have done, which me personally, if I was doing this problem, I would have done it. I would have just flipped it over right away. Said, oh, I need that on this side, so let's just rewrite the equation. So if you guys did that, good job. That's a good first step. That's how personally I would do it. But I don't like to teach just that way, because some students don't even think to do that as their first step. So, but that to me would be the magical first step, because then you just have a one-step problem. Move the 1/2 y over. So just FYI, 2 different ways to do this. Doesn't matter which one. Add your constant first, or just flip the equation at the beginning when you see that's going to be a blank, and then your only step is to get that 1/2 y over. Okay, so we have our constant on the right. Now we need all of our variables on the left. So the opposite of plus 5/2 y is minus 5/2 y. And you can put that in your calculator, or you can do it in your head. 1/2 minus 5/2 would be -4/2 y, which is -2 y, but that's kind of a lot to do in your head. So let's just do it. Practice on the calculator is always good. 1/2 minus, that's subtraction, 5/2. And that'll tell you it's -4/2, which is -2y. So -2y equals, this is gone, 3. So there's my new problem. -2y equals 3. Opposite of times, divide. And there's another improper fraction, which is perfectly fine. One thing teachers and Alex are kind of picky about is no negatives in the denominator. So when you go to rewrite this, just move it up. And that's one of the things that's on the test. It asks you if these are equivalent. And you can see it on the front of your practice test too. Are these two equivalent? And the answer is yes. And there's actually another one that's equivalent, and that's this. So these are all the same thing. Why? Because a negative divided by a positive is negative. A positive divided by a negative is negative. This is negative. They're all 3 negative, and they all are 2 divided by 3, 2 divided by 3, 2 divided by 3. So these are equivalent. So when you have one in the denominator for a final answer, just either 1, bump it up in front, or 2, preferred method, bump it into the numerator. So it does not matter. What matters is each problem has 1 negative, which means they all 3 have negative answers. -2/3, -2/3, -2/3, all equivalent. So that's what we're doing here. We don't want to leave negatives in the denominator, so we bump it up and make it positive. So that would be y equals -3/2. And no need to change it to a mixed number. Like I said, fractions are almost always accepted. So I hope you guys did well on that one. I'm sure you did if you've been practicing in Alex. Okie dokie, let's do these last two and then we'll start with this on our next video. So I just want to get through this section. So now these two both have work to do on each side. None of the problems have had work to do yet, but these two both require work. So on the left side here, I have, let me pick a different color. I have 2 like terms. On the right side here, I have 3 like terms. So this side will turn into negative 5x. I always like my x in front, so I'm going to put it in front. And then this side, 20 minus 5 is 15. Minus 3 is positive 12. Or you could do 20 minus 3 is 17. Minus 5, positive 12. Order doesn't matter as long as you watch the signs. So now it's a simple problem. It looked like a big ugly problem. Now it's super simple. 2 steps, done. So I might want to put a 1 in front of here because I'm going to be bringing it over here, and I need to remember that that's a 1x. So the opposite of positive 1x would be negative 1x. Negative 1x. And that leaves me negative 6x, because when the signs are the same, we add and keep the sign. These cancel. That's the reason we did the opposite. Equals 12. Opposite of multiply by negative 6 is divide by negative 6. And so we get x equals double negative, gone. 1 negative, negative, 12 divided by 6 is 2. So x equals negative 2. And I'll let you guys do the last one before we stop the video. So go ahead and do F on your own, and then we'll compare answers in just a moment. Okay, so hopefully the first thing you did is distribute. So this would be 21x plus 18. So 3 times 7x, 21x, 3 times 6, 18, equals 10 minus 2, positive 8. So first thing is always distribute and combine like terms before you move anything. So there's no like terms here, so I'm ready to start moving. All x's on the left, done. Everything without an x, which is called a constant, moves to the right by doing the opposite because we're crossing the equal sign. So 21x equals negative 10. And then divide both sides by 21. And again, fractions are fine. Just make sure they don't need to be simplified. There's nothing that goes into 10 and 21. The one thing you never want to do is change the answer to a decimal, ever. Because look what happens. Negative 10 divided by 21. And then students just decide they're going to decide how many rounding places, and they'll write negative 0.5 or negative 0.48. You will miss it every time. In higher level mathematics, we want exact answers unless otherwise specified. There is nothing that says round in these directions, so you would never change any of these fraction problems into decimals unless asked. And that's another thing I notice students from high school are really eager to do. They boom, want to get right in there and start changing stuff to decimals. Nope. In college, we want exact answers unless stated otherwise. Okay, we're going to go ahead and call it a day on this, and we'll start here with our next video. We'll see ya.